Okay, so let's go through some practice on chapter 12. So I'm going to use chapter 12 worksheet on D12, and I'm going to show you how to use Excel to get this done. So we are going to talk about how to get scatter diagrams. We talked about scatter diagrams in my lesson. So you can see how to get that. And then linear regression. So how do we get the regression equation? So how do I build y prime equals to a plus bx formula? And then we're going to talk a little bit about how do we predict y for a given x. What you simply do is you plug in x into the formula and simplify. And then third, you're gonna see how to get a correlation coefficient. And then coefficient of determination. Well, actually, these two can be done in one run. You can get the linear regression equation, correlation coefficient, coefficient of determination, everything in one run. And then scatter diagram in another run. And they both located in Megastat. If we go to data, Megastat, correlation and regression. So the very first option, scatter plot, is going to generate the scatter plot for you. And then the last one, regression, is going to generate everything else for you. Okay. So in order to run either, we need to have the data typed in your Excel sheet. Okay. So this is chapter 12 worksheet. I'm going to go through a few questions from it. Okay. So question number 1 says, data is collected from 12 salespeople in order to verify that the more contacts made with potential clients, the greater the sales volume. A scatter diagram of the collected information is shown below. Okay, so you can see the dots are for the actual observations. So they have observed based on number of contacts how much sales that they have made. So by looking at the scatter diagram, what is your conclusion about the relationship between sales and the number of contacts made? Okay, so what do you think? So I'm going to download this. Okay, can I? Yeah, so let's save it. Desktop. Okay, so I can open it here. What is that? Okay, anyhow, so when you look at the scatter diagram, you can see that it's increasing, right? So just imagine a straight line across this data set. So this would be, so you can see the data points are actually fairly closely gathered around a straight line, and it's increasing, right? So you can say there is a there is an increasing, there is a, let me say, a positive, linear association, relationship between contacts made and the sales volume. Okay, so you can add more words to this explanation. Like I said, when you look at a scatter diagram, people can have different opinions, but everybody could agree that it's increasing, right? Overall, it's increasing. But you may have different opinions based on how well it looks like a linear association or not. Some of them may say, okay, it looks like a strong linear association. Some of you would say, no, it's not. It's just a moderate linear association. So that part could vary in an answer. If you have to predict about the association between two variables using a scatter diagram, your answers may slightly vary, and that is okay. Right. So now we have the data set. So this is the scatter diagram. Actually, this is the scatter diagram of this data set. So you have number of contacts made and the sales. So just now think about this. Part A says, what are the dependent and independent variables? So you need to think, what am I changing and what am I looking for when one variable changes? So I'm looking for the change in sales based on the change in number of contacts. So I'm changing the number of contacts made, so then I can see if that is going to impact on sales. So number of contacts is my independent variable and the sales volume is my dependent variable. Right. So now on part B, obtain the linear regression equation. So now you have to type. So let's see if I can have this side by side. Okay, so number of contact and then sales. Okay, let me get rid of all these. Okay, 14. The sales 24, 14, 8. So just to make sure you are typing everything correctly, because if you mistype anything, your numbers are going to get differently, right? So make sure you double check, especially during an exam. Make sure you double check your numbers. Okay, right, so you have x versus y. Then we go to megastat, correlation and regression. So first I will show you how to get the scatter plot, then I will show you the regression output. So when you go to scatter plot, you need to provide what is your horizontal means x variable, vertical means y variable, right? So what's your x variable? It's the number of contacts. You can use the label, which is fine, and then y variable sales. Select it. Okay, x and y are done. And then uncheck this. You don't, well, it depends. If you check this one, plot linear regression line, it's going to emboss a regression line on your data. But if you just need the scatter diagram, just imagine that you only need the scatter diagram, you can uncheck that. So I'm going to run it without it, and then I'm going to run it again with it. So you can add a title if you want. Sales volume versus number of contact. Okay, so this is going to decide the pattern. Markers, are we going to have dots? Do you want lines? So just leave it as default. Click OK. Okay, so this is the output without the linear regression line. So there's a big gap here, right? That means we don't have any actual data in this region. They didn't observe anything in that region. And if I run it again with plot linear regression line with that checked, okay, so here you go. So you get the linear regression line. So least square will be applied to your data set, and this is your regression line, and this is correlation of determination. So some summaries will already be there on the scatter diagram. And for connect homework, I don't recommend using this because this has lesser decimals, right? So you will run into the decimal problem again. So to avoid that, don't use this one. Use the proper regression analysis. So that's next. So third one, correlation regression and then regression. So similar idea, you select, and this time since we are not building any graphs, you don't need to select the label, just only select the numbers. Okay, and this part is for prediction. So if you want to know what would be the predicted y value for a given x, you have to provide that. So we will look into that using a different question. And you don't need to do anything here. They're all advanced stuff. That's it. So you click OK. It's going to create a big output. Oops. What is this? Let's see. Okay, worked. And ANOVA table, this part, disregard it. We are not going to do that. I'm going to get rid of it. And then up here you have correlation coefficient and coefficient of determination. We need that. And down here, so the highlighted ones. So I'm going to highlight it using a different color because you already have yellow in here. So the blue highlighted ones are the only thing we need, right? So regression output, this is your y-intercept, minus 12.2010. That's your y-intercept, A, simple A in the equation. And this is the slope. So if I build the equation right here, y prime equals to negative 12.2010 plus 2.1946x. That's your regression equation according to your data set. And the reason I said you can have more decimals is when you click on any number and you look up here, you get to see a whole lot of decimals, right? So if you need more decimals when you complete your connect homework, look into that. Okay, so for any number, you get to see a lot of decimals. Okay, right, so back to the question. So I know the equation y prime equals to negative 12.2010 plus 1946x. Okay, then let's add the next page. Part C, what would you say about the association between two variables? So for that, you need to look at the regression equation. So in your regression equation, specifically you have to look at the slope. So you can see slope is positive. So if the slope is positive, this is an increasing pattern, right? So you can say positive linear association. Okay. And number 3, suppose the least square regression equation is this. Predict y when x is 3. So you already have the regression equation. 2 plus 1, 1, 3, 3x. So we need to predict what would be the y value when x is 3. So all you have to do is you just plug x equals to 3 into the equation. So 1202 plus 1133 times 3. Okay. Simplify and get the predicted value. Very easy. Number 4. In the least squares equation, y prime equals to 10 plus 20x, roughly sketch the regression line and predict the relationship. So, sketching the regression line, you need to look into the slope. Slope is positive, right? So this is increasing. And the use, you can actually really use 10. The y-intercept in here. Y-intercept means the place where the line crosses the y-axis. So if this is 10, so the line passes through 10 and it's increasing. So just a rough sketch. Y prime equals to 10 plus 20x. And since slope is positive association. Okay. And then number 5, below is the dataset gathered to study the relationship between annual payroll and the number of wins in a season of 9 teams. So if you think about this, you want to figure out is there any association to your payroll based on the number of wins. So when number of win changes, would that impact the payroll? So I think this is about a baseball player or some sort of a sports player's payroll. So they want to know, has their payroll attached to the wins that they make, right? So scatter diagram is the first part. That means I need to type this data set. Okay, so I'm going to pause the video and then type it in. Okay, so here is the data set. First question, scatter diagram. So the horizontal line is the wins, x variable, independent variable, payroll is the y dependent variable. Versus wins, I'm not going to have plot the regression line on it. Click OK, here you go. That's the scatter diagram. So if you just imagine a straight line, I would say overall it's increasing, but it's not a strong linear association. If you imagine a straight line across this data set, it seems like it's scattered. It's not gathered closely around it, right? So this seems like a moderate linear association to me. Okay, so that's part A. Then part B, obtain the regression equation for the above data set and predict the payroll for number of wins equals to 99. So this is a good one to understand the idea of predictions. So first let me obtain the regression line, going back to Megastat. So this time I'm gonna run the regression. Okay, I'm only selecting the numbers. And like I said, you can add the predictions or you can actually do it manually. Just a simple math, right? So the prediction, if I read again, so I need to predict the payroll when the number of wins is 99. Okay, so if I'm going to do it here, type in predict a value and 99. So I need the y value when x is 99. Okay, I'm going to keep getting this. Okay, so I'm going to delete the ANOVA table. I don't need that. I'm going to highlight the ones that I only going to use. So this is the regression output. So first, let's write that down. So it's y prime equals 2 minus 13.156. That's the y-intercept. 0.5432 plus 0.54. Come on. 5432. 32x. Oh, what is this? Sorry about that. This is giving me a headache. Okay, so 5432x, don't forget x over there. Okay, so this is the regression equation, and this prediction part you can actually do it using the Megastat output, or you can just plug in. So all you have to do is, if you want to do it the manual way, just plug in 99 here and then you just simplify this equation. Or else if you go back to the output, this is where you read the predicted value, which is actually very straightforward reading. You don't need to do any math. So when x equals to 99, predicted y value would be 40.3579. So actually the predicted y, so predicted y variable is the wins, right? Wins equals to 40.357. So, and these are all, let me quickly go back to the question. So these are all in millions. Okay, so keep that in mind. Your y variable is in millions. So you may have to put that over here. Okay, so if there's anybody who would win 99 games or goals or whatever, their predicted payroll would be, sorry, not wins, predicted payroll. Predicted payroll would be $40.357 million. Okay, so when you go back to the question, you can see in the question, these are your actual data, right? Wins versus the payroll. You can see when you scan through the wins, 99 is not there. That means they didn't observe 99. Even though they didn't observe 99, because of the regression equation, we could predict it. We could predict the payroll for 99 wins. So that's one other use of regression equation. You can predict y values for given x values. Okay, and then obtain the coefficient of correlation, interpret. So going back, correlation is just R. This is R. So R equals to 0.585. Okay. 0.585. So look at the sign, positive. Look at the magnitude. It's well, it's actually kind of the middle, right in the middle between 0 and 1, right? So I would say I would go with the weaker side, because when you look at the coefficient of determination, it is fairly low, right? So I would say positive, weak, linear association between wins and the payroll. Okay. And then it's asking comment about all three results. So from regression equation, we actually couldn't predict about the strength, but only thing we can predict is that it's a positive association. And then from here we learned, from part C, we learned that it's a weak linear association. So you can basically summarize the same thing over here. Okay, and then number 6, again, you have to get the coefficient of correlation and make your conclusion. And we didn't talk about the coefficient of determination there, so I'm going to go back and look at that number from the Excel output. So I'm going to add my own interpretation for that. So R square, coefficient of determination, equals to 0.342. So what does that mean? If the question asks you to interpret, that means 34.2% of the variation in payroll is due to wins. So this means this is a fairly low percentage. This means we need to look into further analysis. The analysis using multiple regression or nonlinear regression. So 34.2% of the variation is determined by number of wins. So that means a player's payroll is not solely depend on the number of wins. There has to be some other factors involved, right? Deciding their payroll. So that would be the appropriate conclusion to make in terms of coefficient of determination. Okay, and since this is the same data set as we had before, number of contacts and sales, so we can answer this question as well. What is the value of the coefficient of correlation? Is the manager right about the relationship between the number of contacts and the amount of sales? So since I already have the regression output here, the previous output, there you go. Okay, so this is the output we did for that question. And look at this. R is 0.975. Correlation coefficient is 0.975. It's positive. It is very close to 1. So positive, very strong linear association between number of contacts made and okay, come on. And the sales volume. Okay, right, and then I'm going to write down a statement about the coefficient of determination over here. So R square is 0.951. So 95.1% of the variation in sales volume is due to the contacts made. So you don't need to look into any further analysis. This is very clear that the major factor which decides the sales volume for this company is how much contacts that they were managed to make, how many customers they managed to contact. That is the key factor which decides the sales volume. So the manager may be correct about making higher number of contacts so they can reach maximum sales volume. Okay, right. So done all the questions in the worksheet. So it's just a repetition. So scatter diagram, regression analysis, correlation analysis, coefficient of determination, 4 different things done through Megastat. Everything can be done through Megastat. So you get all the numbers and then go through my lesson once more to learn how to interpret those numbers. How do I interpret and use regression equation? How do I interpret and use correlation coefficient? How do I interpret and use coefficient of determination? Okay, right, so that's it.